In today's lesson, we're going to be looking at absolute value and then taking that to the next level and solving some absolute value equations. We'll talk about absolute value inequalities next week. So what exactly is absolute value? It's represented by these parallel lines, and there's generally a number in between, and it's saying how far is this number from the origin? Let me use one that fits on my number line. Let's just say we'll start with 3. Well, the absolute value of 3, and 3 is represented right here on the number line. How far is that from the origin? 1, 2, 3 spaces. So the absolute value of 3 is 3. Let's now look at a negative number. Let's look at negative 3. Well, negative 3 can be represented by a solid circle on the opposite side of the origin, and it is now 1, 2, 3 spaces from the origin. So how far is it, or what's the distance from 0? And absolute value is always positive. So if absolute value is always positive and we want to find the value of x, we're going to find out that there could be two possible solutions for x. The absolute value of 3, as we saw on the last slide, is 3, and the absolute value of negative 3 is also 3. You can write it as two separate solutions, or you could do x is equal to the plus or minus of 3, the positive or negative. Now, every time we solve an absolute value equation, we are going to get two solutions. We're going to solve it once, exactly as we see it, because whatever this value is within this grouping has to equal 7. But we also know that that value could also equal negative 7. So we'll solve twice. In the first, I'm going to subtract 5. I'm going to get x is equal to 2. In the second one, I'm also going to subtract 5. And my other possible solution is x is equal to negative 12. Let's see if that works. All right, let's start with replacing x with 2. Well, 2 plus 5 is 7, so the absolute value of 7 is 7. So the first one works. We always want to check to make sure that it works. In my second one, I start off with the absolute value symbol, and I'm going to get negative 12 plus 5. The question is, does that also equal 7? Well, negative 12 plus 5 signs are unlike. We subtract and keep the sign of the greater absolute value. That gives me negative 7. And we know that absolute value is always positive, so negative 12 works as well. Let's try a couple more. We'll do another one step, and we'll do a two step. Let's try these both. Once again, as I'm solving an absolute value equation, I am going to solve twice. I'm going to solve once with it equal to 9, and once while it's equal to negative 9, because what fits inside that absolute value symbol could either be 9 or negative 9. I'll then use one inverse operation. I get x is equal to 12 as one possibility. I'll add 3 to both sides, and I get x is equal to negative 6 as my other solution. 12 minus 3 is 9. Absolute value of 9 is 9. Negative 6 minus 3. Does that equal 9? Well, subtraction says to add the opposite. And negative 6 plus negative 3 equals a negative 9, and the absolute value of negative 9 is 9. It works. The same is true with a two-step. Solve it once and solve it twice. The second time, the only thing you're changing is the sign that it's equal to. You'll add 1 to both sides. You'll get 2x is equal to 12. Divide by 2. X is equal to 6. I'll add 1 to both sides. 2x is equal to negative 10. And I'll divide by 2. x equals -5. So you see that we're using what we know about solving equations to apply that now to absolute value equations. And when we solve absolute value equations, we must solve twice. We're going to find that what goes inside that symbol could either be a positive or negative number because we're measuring distance, and distance is always positive. We'll do more in class.